We have one more example of a phase shift in this section, and then we have one more type of shift that we're going to discuss. So picking up from last time, we're on example number 7. So we're going to identify the amplitude, period, phase shift, and as I mentioned before, this piece should not be a part of the directions on this one. So we're going to look for y equals 1/2 cosine of 1/2 x minus pi over 4. All right, so on this one, the amplitude is 1/2. And I notice as I'm seeing this that we didn't actually find the period for the last two. So I'm going to pause real quick and we're going to go back and find the period for them. They're not difficult to find, but I did not pay attention carefully enough to notice that was part of our directions. And in case it is part of your directions on your my math lab work, I want to put that in there here. So I'll put this in yellow so that we're noticing that we've added this in. So the period is still 2 pi over b. So it's 2 pi over whatever is multiplied in front by x, which is still a 1 here. So this would be 2 pi on number 5. On number 6, it's exactly the same. We have, and I'll put it in here as well, 2 pi, and it's divided by the number multiplied by x, which is 1, so it's still 2 pi. On this one, though, it's different, right? So our period on this one is 2 pi, but it's divided by the number multiplied by x, which is actually a 1/2. So 2 pi divided by 1/2 is actually 4 pi, so our period is 4 pi. Now, our phase shift. So for our phase shift on this one, we're going to set it up 0 and then 2 pi, right? It is still 2 pi, by the way. I realized that I just told you that the period was 4 pi. All of that will flesh itself out when we solve this inequality. So you don't need to set it up any differently. It's always 0 to 2 pi. So 1/2 x minus pi over 4. All right, so for starters, we're going to add pi over 4 to all three sides. On the left, that's exactly pi over 4. In the middle, I now have 1/2 x because these added to 0, which was the whole point, right? And then over here, 2 pi plus pi over 4 is 9 pi over 4. Remember common denominators. That's one way to do that. You're welcome to use your calculator to simplify that too. But you're going to get 9 pi over 4. And then the last thing is to notice that we've got 1/2 in the middle, so we're going to divide by 1/2. But we could also think about that instead as multiplying by 2, which is a little friendlier. So if we multiply by 2, so we end up with pi over 2 on the left, x in the middle, and then 9 pi over 2 on the right. And then we're going to take the graph and we're going to, oops, that didn't look very good. Let's try that again. That's a little bit better. Our amplitude goes up only this time to 1/2 and down to negative 1/2. If you want to draw in the 1, just to remind yourself where that would be, that's totally fine. You certainly don't have to, but if it helps you to sort of a better picture, that's fine. It's going to start at pi over 2, and it's going to go to 9 pi over 2. We're going to cut it in half. Halfway between 9 pi over 2 and pi over 2 is 5 pi over 2. And then we're going to make the marks to cut it in half again, but I'm not going to make you label them. I'm good with that. And then this is the cosine graph. So the cosine graph, it starts at a peak and it ends at a peak. Halfway in between, it has a minimum value, which actually these values are a little bit too big. So let me shrink the size of my 5 pi over 2 just to give me some space. That's not going to be any better. Let's try it again. All right, that's going to have to suffice, I suppose. So here's my point for that one. And then we cross the x-axis at the other two. We'll connect them with a sinusoidal graph. Looks something like that. All right, the last type of shift is called a vertical shift, and this one's pretty simple to do. It does make things look a little weird in some ways, though. So instead of shifting things left and right, a vertical shift shifts the graph up and down. So if the value is added to a trigonometric function, it creates a vertical shift. If the value is positive, it shifts up, and if the value is negative, it shifts down. So we're going to use the vertical shift to graph one period of the function. Now notice it doesn't ask us for these things, but I'm going to still put in the period and the amplitude. We did amplitude first. Okay, so the amplitude on this is going to be 1, right? And the period is 2 pi. Notice how this looks different than the last one. We see cosine of x minus 2, but it's not like this, right? It's not grouping the x minus 2 together. The x and the minus 2 are separated. So this negative 2 then, what it's going to do, it's going to move the graph down, because it's negative, 2. So our graph normally would have gone from negative 1 to 1, right? And if I shift it down 2, instead of from negative 1 to 1, it's going to go negative 3 to negative 1. All right, so what was going to be negative 1 to 1 is subtracted 2 from it, and it's negative 3 to 1. And so I've got an amplitude of 1. It should have been like this, but then it gets moved down 2, so now we're down here below the x-axis. The period should be 2 pi, so we're going to mark out 2 pi, and marking halfway between and labeling it, it's pi. And then you don't necessarily have to label the other two, although we've done them frequently enough, we might as well. It's pi over 2 and 3 pi over 2. All right, so it's supposed to start for a cosine graph at a peak. The peak normally would be here, but it needs to be shifted down 2, so it's going to be here. And then it needs to go back up to that point when we get over to 2 pi. I'm going to shift that up a little bit so I can get there and put my point there. Halfway in between, it has a minimum. That would be down here now because it is shifted down 2. And then we have the points that are in between. One way you can do this, if it's helpful to you, is you can kind of draw in the shifting of the x-axis. So the x-axis was at at the x-axis, the center values, right? But now they are down 2, so they're right here. So if it helps you to sort of shift the axis down with a dotted line as a reference point, you can do that. And then we're connecting these with a sinusoidal graph, so it looks like this. All right, we have one more. This one has a lot going on, so we're going to write down the pieces that we have. So the amplitude is 3. Remember, it's the absolute value. We do have a negative right here. This negative means that we're going to have a reflection over the x-axis. Our period is a little different, right? Our period would be 2 pi divided by the 2 pi that's multiplied by x. So our period is 1. And then this last piece over here tells us we are going to shift up 2. And I promise you the shifts are not always 2. They just were on the 2 I gave as examples. They're 2. So we're going to draw in our axis. We're shifting up 2. So I'm going to do this differently than I did last time. I talked about this last time, but we'll do it in a different order. So previously we would have had it go from negative 1 to 1. Now our amplitude is 3, so it would be negative 3 to 3, right? So we should be going from negative 3 to 3. But the plus 2 on the end takes the x-axis and it shifts it up 2. So shifting my x-axis up 2 would be putting my x-axis basically right here. So what I really need to do is I need to go up 3 and down 3 from there. So I've got the down 3 part from there still kind of drawn in because I've labeled enough pieces. To go up 3, I need to be able to go up a little bit further than I currently am. So I'm going to extend this a little bit. Here's up 2 from the orange dotted line, and here's up 3. So that would be up to 5. So from the orange line, I need to go up 3. That'll be up to 5. And I need to go down 3. I will go to negative 1. So let me label the negative 1 as well. All right, so my period is 1. So not pi, 1. I'm going to go out to 1. I'm going to half it. That's 1/2. Halfway between those is 1/4, and then 3/4. All right, this is a sine graph. A sine graph starts at an x-intercept, but my x-intercept has been shifted up to the orange dotted line, so this is where my sine graph will start. The sine graph typically goes up first, but because of the reflection over the x-axis, it's going to go down first. And it's going to go down 3, which means it's going to go down clear to the negative 1 right here. That's down 3 from the center line. Then it's going to go back up to the center line. Then it's going to go up 3 to 5 there, right? And then back down 3. Get that a little bit more centered there. And then back down 3, which is back down to the dotted orange line. So my graph's going to look like this. Okay, so let's just check and make sure it has all the features. Did we have a reflection over the x-axis? Yes, we did. We went down instead of up. Did we have an amplitude of 3? Yes. From the dotted line, we went down 3 and up 3. Do we have a period of 1? Yes, we went from 0 to 1. And did we have a vertical shift of the 2? Yes, that was my dotted line shift of the 2. So we've met all the criteria, and this would be our graph.